Okay, so this lesson is 2.6, the chain rule. It's basically the last derivative rule that we need to learn. Before I explain to you sort of what the chain rule is, or before we apply the chain rule, I'm going to show you how we could do these three just on derivative knowledge that we have up to this point. So it says differentiate the following functions by first expanding and then taking the derivative. And basically what I want to see is if we're going to notice a pattern. So y is equal to x minus 1 squared. So we know that that would be x minus 1 times x minus 1. That would be y is equal to x squared minus 2x plus 1. Then we could use our sum or difference rules to apply, and the derivative, so y prime is equal to, so the derivative of x squared would be 2x. The derivative of negative 2x would be minus 2. The derivative of 1 is 0. This is the answer, but in order to see this pattern that's going to exist with the chain rule, what I want you to do is I just want you to factor this answer. Normally you would just box this in, but let's factor this answer. So y prime is equal to 2x minus 1. Okay, let's do this one, and then let's stop and see if we could sort of see what the pattern will be. So again, y is equal to x plus 5 and x plus 5. Y is equal to x squared plus 10x plus 25. Y prime is equal to 2x plus 10. And let's factor. We're going to get a 2x plus 5. Okay, does anybody sort of see a pattern that's being developed here? So I want you to look at this derivative answer, the factored answer, based on what we initially started with. So what do you see? So for example, x minus 1, x minus 1, x plus 5, x plus 5. What do you think the bracket's going to be in this one? X minus 7. And then this 2, do you know where that came from? It probably came from here, right? It probably came from there. And what I want you to actually add is there's going to be a number when I actually teach you the chain rule, and there's going to be a 1 for this one, and there's actually going to be a 1 for this one. 2 times 1 is just 2, so I don't need to write this 1, but it will be there, okay? So this one, following the pattern, we're probably going to have a 2 in front if I bring that guy in front, and then we're going to have an x minus 7, and then we're going to have this 1 that we don't really know about just yet. But let's expand and see if that's correct. So x minus 7, x minus 7, y is equal to x squared. Minus 7x minus 7x will give me minus 14x plus 49. The derivative differentiating this would be 2x minus 14. And y prime, if we factor out a 2, we're going to have our x minus 7. And then again, for some reason, we're going to have this 1. Okay, so there is a rule, and it's going to be called the chain rule. And the reason why we want to have a rule that we could be able to do is because if I gave you, let's say, x plus 5 to the power of 4, we want to be able to establish a rule where we could differentiate this without doing x plus 5 times x plus 5 times x plus 5 times x plus 5, and then expanding it. So what do you guys think the derivative based on what we've done so far for this one would be? Anybody want to guess? It's going to be 4x plus 5. Now this one's actually going to have an exponent here. Think about the power rule. It's going to have a 3 here. And then there's going to be a 1. What's that? Nope, you won't need to keep doing it. What this 1 is we're going to apply the power rule. So we're going to bring the 4 down. You're going to keep your x plus 5, and you're going to subtract a 1 here. and then we're actually going to take the derivative of the inside. The derivative of x plus 5 is just 1, and that's where this 1 is coming from. Okay, so it says, what do you notice about the original function and its derivative? It's just like the power rule. The original exponent goes to the front. We decrease the power by 1. So the original exponent goes to the front. We decrease the power by 1. And then it says, however, we must then multiply by the derivative of the inside function. So the inside function, if I took the derivative of x plus 5, well, the derivative of x is 1. And the derivative of 5 is 0. So 1 plus 0 is just 1. So now let's do the chain rule for this one. So we could write y prime, or remember we could write dy dx. So let's do y prime for the first one. So you take the 2, you put it in front. You keep this is called the inside function. So the inside function remains the same, 2x plus 1. You subtract 1 from the exponent, just like the power law, so we'll get a 1 here. And then you take the derivative of the inside. This is called, would be my inner function. What would the derivative of 2x plus 1 be? 2. Yes, because the derivative of 2x is 2. And the derivative, it would be 2 plus 0, so just 2. From here, we would clean up. So we would say y prime is equal to 2 times 2 is 4. And then we've got 2x plus 1. So that's an answer. Or y prime is 8x plus 4. Okay, so this one, dy dx is equal to, so chain rule says, bring down that power, 3x minus 5, that's my inner function, it stays the same, and you subtract 1 from the exponent, and then you take the derivative of the inside, and Alex, what would the derivative of the inner function be? 3. dy dx, derivative of y with respect to x is equal to 6, 3x minus 5. That's my factored answer. My non-factored derivative would be 18x minus 30. Okay, so now let's do this chain rule with more complex functions. And then I'm going to write something down for up here. So remember, differentiate, this is my y is equal to, with respect to x. So take the derivative of this. So this equals 7 comes in front. We're going to get 9x minus 6. Subtract 1 from the exponent, so it's going to be to the power of 6. And then take the derivative of the inner function. And Emily, what would the derivative of the inner function be? 9. Okay. dy dx is equal to 7 times 9 is 63. 9x minus 6 to the power of 6. And we're not going to expect you to expand that out. It will be done. Yes. Okay, so if I said to you, if I wrote this, this is saying take the derivative of this function with respect to x. So the answer to this would be, what is the derivative of this? And I would use my power rule. So it would be 12x to the power of 3. Okay, so, or this could also be written as y is equal to 3x to the 4. And then they could say differentiate that. So then we're differentiating y, dy, with respect to x. The derivative would be 12x to the 3. So this is just basically telling you take the derivative of this function. This function is normally y. Yeah. Okay, let's do this one. So take the derivative of this function with respect to x. So 4, 3x squared minus 7x, power of 3, times the derivative of the inner function. Kayla, what's the derivative of the inner function? That's right, 6x minus 7. And that would be my answer. That's my derivative. I can't simplify anything. Let's do this guy, and then we'll go up. So the derivative of this, so I could write dy dx if I want, is equal to 5, 6x3 minus 2x to the 4. And then, Akil, what am I going to multiply that by? Yes. Now, this one of my factors, actually, yeah, you can out of both, but you know what? This one, it's like there's 4 of these, which gets really messy. So you know what I'll do? Let's just factor out from here a 2. dy dx is equal to 5 times 2 is 10. And then that bracket would be 9x squared minus 1. Oh, that's actually a difference of squares if I really wanted to. 3x minus 1, 3x plus 1. And then this guy, 6x cubed minus 2x to the 4. Yeah, this one would be messy because, Carly, yes, you could actually from here factor a 2x out of here, but there's 4 of them. So I would never give you something that messy on a test, but just realize that we could, right? If it said, give your answer in fully factored form, we would need to do that. Yeah. On like any quiz or exam questions, probably how it would be set up is you couldn't factor anything from this guy. And then this one, you probably could. Okay, this one, let's rewrite this. They want me to take the derivative of 2x minus 1 to the 1/2. So now use your chain rule to deal with this. So derivative of y with respect to x, 1/2 goes in front. And we're going to get 2x minus 1. What's 1/2 minus 1? Negative 1/2. And then, Karis, what's the derivative of the inside function? It'd be 2. 2 times 1/2 would be 1, or the 2 over 2 would cancel. And that 2x minus 1 can be written in the denominator, so make that negative 1/2 positive. So bring it down, and I'm going to actually turn it back into a radical. And we'd have 1 over the square root of 2x minus 1. Okay, so what's actually happening is we've been doing what's called composite functions. So let's just say I give you f of g of x. This is actually chain rule. We've been dealing with composite functions. So if I say I want you to differentiate this, so I give you a composite function, I want you to take the derivative of it. What we've been doing is we have been taking the derivative of the outer function. So the outer function is bringing that 7 down and then subtracting 1. So what that would look like is we've been taking the derivative of the outer function, which would be the outer function between, actually, sorry, I should make this little f. Okay, so if it was written like this, what's my outer function between f and g? F. So what it's going to look like is we take the derivative of the outer function, so that would be f prime. The inner function, we've been keeping it exactly as is, right? So we've been bringing the 7 down, and then we've been keeping the inner function exactly as is. So the inner function is g of x. And then we've been multiplying it by the derivative of the inner function. So that would be this 9x minus 6. The inner function in this case would be g of x. So the derivative of that would be g prime of x. So it's chain rule applies to composite functions. You take the derivative of the outer function, you keep the inner the same, times the derivative of the inner function. That's what we've been doing. Okay, so let's sort of look at this. Chain rule. So this is f of g of x. Okay, so we take the derivative of the outer function, whatever the outer letter is, which is f. So f prime. We've been keeping the bracket, which is the inner function, the same. The inner function is g of x. And then we've been multiplying it by the derivative of whatever this bracket is, which would be g prime of x. Okay, that's what we've been doing. So if you look at this would be a composite function. This is my outer function, and this is my inner function. So the derivative of this, dy dx, is equal to, it's the derivative of your outer function. So it'd be f prime. You keep your inner function the exact same, x cubed, times, now we take the derivative of the inner function. What would the derivative of the inner function be? 3x squared. Yes. And that would be the answer. So again, if I gave you this, differentiate with respect to x, and I want you to differentiate, let's say, 2x plus 1 to the 3. Okay, so this is considered my my inner function. So what we've been doing is we've been taking the derivative of the outer function. So bring that 3 in front. Keep the inner function the same. And then 3 minus 1 is 2. And then we multiply it by the derivative of the inner function. The derivative of the inner function would be 2x plus 1. So derivative of that is 2. dy over dx is equal to 3 times 2 is 6. 2x plus 1 squared. I'm going to do one homework question with you, and then I'm going to give you a bit of time to do number 1 in your homework. And then we'll start part 2, which is something called U substitution, and then we'll finish it off tomorrow. Okay, so for your homework, I want you to do question 1, A, C, E, G, I, K, and we will do K together, and then you guys will do the rest of these. So just write down, here's question K. And I believe what it says, number 1 just says find the derivatives of the following functions. So sorry, you're going to be doing number 1 left-hand column in your book, and we'll do K together, because the other ones are quite straightforward. Okay, so first thing I want you to do is I want you to rewrite this. Take this out of its radical form, because we want to be able to apply chain law in here somewhere. So rewrite this, take this out of its radical form. So write it with a fractional exponent. So that would give us x minus, now remember there could essentially be a bracket in here. So it would be 1 plus x to the 5 minus 6x to the 10. And what would the fractional exponent for this be? 1/5. Okay, what we have is we've got a combination of two derivative laws basically happening. This can be looked at as two separate terms. So I would do the sum or difference law. I'm going to take the derivative of this minus the derivative of this. Now, the derivative of x is easy, minus this one is going to be a chain rule. Okay, so we could write dy dx. So let's do our difference law. So Sarah, what's the derivative of x? 1 minus, and then let's apply chain law to this, or chain rule. So 1/5 comes to the front. Keep the inner function the same. And we're going to subtract 1. When I subtract 1, Shaywa, what will I get? Yep, -4/5. And then Carly, what do I do from here? Times the derivative of the inside. What would the derivative of the inner function be? Yep. And then where your answer stops this question in the book is they just clean this up by getting rid of your negative exponents. So clean up this by getting rid of your negative exponent. So dy dx is equal to, and then I'll show you later on how we could clean it up further, but for now, 1/5, 5x to the 4 minus 60x to the 9, all over, and that would be to the 4/5. And then I don't know if your book actually stops there. Let me just look at my key really quickly. Or does it write that as a radical? Okay, so your book would actually stop at that spot. Um, but because it had a radical in the question, I'd probably take it one step further and say 1 minus 5x to the 4 minus 60x to the 9 all over 5. And then it would be the 5th root of to the power of 4. No, so this lesson is just, can you do chain rule? So later on, what we would actually do, Carly, to clean this up is we would actually get common denominators and then see if I could factor anything from here. But this is too messy. So that's why the book just stops it here. Yeah. Eventually we will be doing that, but we would have cleaned up the question. It wouldn't be this messy. Okay, so that's what I want you to work on right now is 1, 2, 3, 4, 5, those 5 questions. And then we'll start something called U substitution, and I'll finish it off tomorrow.